245 feet thick water as part of a vast lake. Although this vast lake is clearly no longer present, nearby fresh-looking lava flows indicate the possibility of future volcanic activity occurring here. With the exclusion of these three young 10,000 to 15,000-year-old lava flows, the dozens of regional vents which erupted through or adjacent to this ancient lake comprise what is known as the Fort Rock Volcanic Field. The Fort Rock Volcanic Field can be found in central Oregon, where it is 25 miles east of the town of Gilchrist. The namesake of this field, Fort Rock, forms an impressive ring-like structure in the center of the volcanic complex. Because of this ring shape, this landform is known as a tuff ring. So, how did Fort Rock form? Heading to a time 75,000 years ago, much of central and southern Oregon were covered with large lakes related to the vastly different colder climate from the ongoing Ice Age. One of these lakes was known as Fort Rock Lake, and covered the entirety of the modern-day towns of Christmas Valley, Silver Lake, and Fort Rock. In fact, here are the depths this lake reached during its maximum extent, covering an area comparable in size to the modern Great Salt Lake in Utah. This area marked the very western edge of a unique volcanic province known as the High Lava Plains. Volcanism in this region was triggered by the fact that a section of the Fort Rock Formation subducting Juan de Fuca Plate had in geologically recent times snapped downwards at a deeper angle. This caused material in the mantle to rush upwards and fill the previously occupied space, soon rising into the crust and intruding as magma. After reaching shallow depths, the heat from the rising magma interacted with wet sediment beneath the lake, causing water within them to flash to steam and greatly expand by a factor of 1700. This built an incredible amount of pressure, eventually becoming sufficient to break overlying rock, resulting in magma and steam exploding upwards, ejecting debris to form a ring structure of debris which was 2,300 feet wide. A total of 35 other tuff rings formed underneath or adjacent to shorelines of Lake Fort Rock between 400,000 and 25,000 years ago. By 20,000 years ago, the large lake was still present, Big Hole, but had receded from its maximum extent. 7.5 miles to the west of the lake edge, a volume of magma once again rose to the surface. Once again, due to the abundance of groundwater in the region, this water was heated and flashed to steam, expanded in volume, and then produced a tremendous explosion, carving out a 6,700-foot wide crater that was 460 feet deep. This feature, known simply as the Big Hole, formed in association with a tuff ring that itself produced multiple smaller explosions. 22 kiloton explosion, the most recent and famous feature in this volcanic complex, formed around 15,750 years ago through a similar process only 6 miles to the east of the Big Hole. As basaltic magma rose toward the surface once again, it interacted with groundwater to create an explosion at 500 feet depth which released energy equivalent to the detonation of 21,500 tons of TNT, or essentially equivalent to the Trinity nuclear weapons test in 1945. This ejected car-sized boulders of rock more than 12,000 feet away, occurring alongside the generation of not only pyroclastic flows that likely traveled 1 to 5 miles away in all directions, but also the creation of an eruption plume which shot to a height of 40,000 feet. As the estimated 75 million cubic meters of ash with minor lava fragments fell back to the ground with winds largely blowing towards the east, it created a raised rim 170 feet high than the original topography. By the time the dust and ash had fully cleared, what remained was a mile-wide maar known today as the Hole in the Ground.